Hello, I'm going to be going over factoring today. Um, this video won't cover the graphing part of it. That will be on a separate part of my website. So you can scroll through it. It'll be a tab. It'll be under the graphing tab will be right under this video if you want to learn how to graph. This is just to go over factoring. So the first type of factoring is known as simple trinomials. Um, it's pretty easy, so give it a little example here. X squared minus 9x plus 14, why not? Now, you can identify a simple trinomial if the a value is 1. Now, in this, the a value is already 1, but you don't have to write the 1 in front of it. Leave it as it is. So, now, in order to factor this, your first step would be to identify your c and b value. In fact, I'll just write it down over here under in our red marker. So this is your ax squared term. This over here is your b term, so plus bx. And this is your c term. In order to factor this, we're going to be using a method called the product and sum similarity. So pretty much what this is to factor it is your two factors would be times this number equals c. This number plus this number equals b. So pretty much two numbers that multiply into c and also add up to the b term. So in this case, our c term is 14. Write down 14. In this case, our b term is negative 9. So we're going to write down negative 9. Oops. Negative 9. So your next step would be to find these two numbers. Now, what will help many of you in this would be to just jot down numbers at the side. So 2, 7. This multiples into 14 but does not add up to negative 9. Negative 2, 7. This multiplies into negative 14, so we already know it's not the numbers. Negative 7, 2. Nope, does not multiply into positive 14. Negative 7 and negative 2. Multiplied, positive 14, added, negative 9. So we know that these are two numbers. Right over here. Two numbers. So we're going to fill these in. Negative 7, negative 2, negative 7, 2. So our next step would be to do the x minus r and x minus s formula. So put these two numbers into that formula, which would be 1, which would be negative x minus 7, and x minus 2. Now, you know you don't have to write the 1 term there. Oops, just going to cross that out, and that will be your final answer. And as I said before, if you would like to know how to factor this, graph it, just scroll down my website. Next page, next tab should be how to graph this onto a graph. But this is simple trinomials. Going to be moving on to complex trinomials now. So, going to be doing complex trinomials now. First example is going to be 10x squared plus 14x plus 4. Now, as you may notice, it's very easy to identify a complex trinomial. To do that, if you look at the a value, it should be more than 1. So you can see it's 10, which means we are working with the complex trinomial. So as we all know, ax squared plus bx plus c. So our first step would be to multiply the a term by the c term. So that would be 10 times 4, which we all should know by now, equals 40. Now, this is going to be our new term for when we do the product and sum similarity. 14, the b term stays as it is. It'll stay the way it is, 14. So now moving on to the product and sum similarity. So what two numbers multiply into 40 and add to our b term, which is 14? Now, just looking at these two numbers, you can see 10 and 4 multiply into 40, but 10 and 4 also add up to 14. Now, after you got this, you don't just write, oh, x plus 10 and x plus 4. That's incorrect. You have to put these two values into this. You could break apart the 14x into two of these numbers. So here, let me show you. What I mean by that is, write out the equation, 10x squared, and then move on. 10x squared plus, what's our first number? 10. I'm going to highlight this actually. Highlighter, 10 and 4, which are going to be subbed into this equation. So 10x squared plus 10x plus 4, plus 4, plus 4x plus 4. So if you go up, our original equation was this, 14x and 4. And all we've done is split this equation into the two parts. So 10x and 4x. And left everything else the same. So these two numbers, these two values have been added in, where the 14x was. Our next step would be to bracket, separate these terms with bracketing. So it'll be 10x squared plus 10x plus, so the sign goes here, depends on whatever's here, plus 4x plus 4. Bracket the term. Now, we're going to be pulling out common factors. There is a little blurb about common factors on my website. You can check it out. But yeah, so in our first bracket, 10x squared and 10, well, they're both 10, so we can pull the 10 number. There's two x's here and an x over here. So we can pull out one x. So our common term here would be 10x. And we're going to divide everything that's in this, this number by everything that's inside this bracket. So 10x is pulled out, and so as you can see, 10x has been pulled out, and we're going to divide it by everything inside this bracket. So first step, 10 divided by 10 is 1. 1x, there's two x's. And x divided by two of these will leave only one x, so 1x. 10x divided by 10x is 1, plus 1. In this, we have 4x and 4, so we can pull out a common term of 4, which would be x plus 1. This, so here is a 1. We don't need to add it in to our equation. And as you can see, oops, make this x a little better. Our 10x is out, and the 4. So as you can see, we've now gotten the common terms out. Now we're going to be grouping them together. So 10x and positive 4 will come in one bracket. Now, you're only going to be writing x plus 1 once. This is because if you were to factor these two, you'd find that they cancel each other out. So you only write one of them. So this is going to be your final factors. So now you're pretty much done complex trinomials. These will be your final answers over here. Again, if you want to learn how to graph this, just scroll a bit down my website and you'll find out how. So we're going to be moving on to perfect squares now. And yeah, so going to be going over perfect squares now. Um, Here's an example of a perfect square. X squared plus 6x plus 9. Now before you get into a perfect square, if you were to make an algebra, if you make it out of algebra tiles, it would be a square, as it is in the name. 1, 2. So if you draw a perfect square, it would be a perfect square. It would be square. So the length and the width would be the same. So this is x plus 2 and x plus 2. That would be what a perfect square would be, just to go over that. So you can find if something is a perfect square two ways. The first way would be to go the complex trinomial way and just factor it out the same way you would the complex trinomial, pull it out, or the simple trinomial, so you can do product sum similarity with just these two numbers right off the bat. So what times what equals 9, 3 times 3, 3 plus 3 also equals 6, you got your answer. Or you can go another way, which is known as, if we check for perfect square, C equals B divided by 2 squared. This is covered a lot more in depth a bit if you scroll down. So in this case our C term is 9, so B term is 6, so 6 divided by 2 squared equals 9, 3 squared equals 9. So we know that this is a perfect square just by checking it this way. Yeah, or you can just factor it. And whatever suits you. If you factor it, it would have been 3 times 3 equals 9, and 3 plus 3 equals 6. So now your factors would be x plus 3 and x plus 3, or your length and your width, if you're thinking about it algebra tiles wise. But there's two of them, so you can just write x plus 3 squared. Now whenever it asks you to simplify anything, you typically want to do this. It makes it look a lot neater as well. So this is what a perfect square is. A lot of times it'll help to maybe just make some algebra tiles. And yeah, but this formula over here, C equals B divided by 2 squared, is very helpful. It can save you lots and lots of time, so I definitely recommend writing this down somewhere and jotting it down on a piece of paper. But yeah, final answer over here, and that was perfect squares. The next one will be difference of squares. So gonna be doing difference of squares now. Difference of squares is when you do an algebra tile and one side is negative while the other side is positive. So boom, x plus something and x minus something. That is how you determine if something's a difference of squares or not. So our example would be y squared minus 144. And the difference of squares is very, very, very easy to identify. There's only two terms, and the second term is negative. So there you go. An easy way to break this apart is there's two y's. How would you break apart two y's? 1y, 1y. How would you break apart negative 144? Well, if I take out my calculator here, 12 times 12, 144. So know that 1 is a positive 12 and 1 is a negative 12. 12, 12. And this falls into the algebra tiles example I gave earlier, a little rough sketch I drew. One side will be y minus 12, one side will be y plus 12. One will be positive and one will be negative. So if I were to do another example of this. You can do x squared minus 400. It'll be the same thing. I can break apart x. There's two x's, so 1, 2, negative 400 can be broken apart by 20, so positive 20 and negative 20. And these two would be your factors. Right over here. That's how you get the difference of squares. It's, in my mind, the easiest to do out of them all, because it's really easy to identify. As you can see, two terms, second term is negative. So you can get your factors very easily using this method. Yeah, so next is going to be factoring by grouping. So going to be going over factoring by grouping now. Factoring by grouping is when you're given an equation. So let's say y squared plus 7y plus 5xy plus 35x. Now, when you're given an equation like this, what you want to do is, there's four terms, there's, a lot. What you want to do is you want to split it up, you want to group it, which is why it's called factoring by grouping. You want to group these terms together. So find numbers that are easy to divide by each other. So 1y squared is 1 and 7 are easy to divide. They both have a variable. You can group these two. 5xy, 5 and 35 divide nicely. They both have a common variable. So you can group these two as well. So after grouping, you can just move down and pull out common terms like you did with the other, with like complex trinomials. So y squared plus 7y, both are divisible by 1, and both contain at least one y. So now 1 divided by 1 is 1, y divided by y squared is just y, 1 divided by 7 is 7, y divided by y is elimination, so y plus 7. And then for the next one, 5xy and 35, 5 can be divided, 35 can be divided by 5, so pull out the 5 term. They both have at least one x, so 5x. Division, 5 divided by 5 is 1. X divided by x eliminates itself. Y is the only one left. Y. 35 divided by 5 is 7. X divided by x will eliminate itself. So y plus 7. So your final factors would be y plus 5x. And then, as I said before, if you were to factor these two, you'd find that they cancel each other out, so you only write 1 y plus 7. Those will be your two factors, your final factors for this equation. So as you can see, factoring by grouping is also very easy. It just requires inspection. Just inspect the equation and find numbers that worked well together and cooperate. So for me, I found 35 and 5 and 1 and 7. I found that they had a common variable, just like I did with these two, which is great. It's always good. So yeah, gonna move on to a little technique known as greatest common factor, which can help you factor. It pretty much consists of taking a number and simplifying it before you even factor. Gonna move on to that shortly. Gonna be going over factoring. I'm gonna be going over the technique of greatest common factor now. So, say we have something like 6x squared plus 2x minus 4. We can identify a common term in both these numbers, which is 2. They're all divisible by 2. So I can pull out a common term out of these already, which is 2. 2 divided by 6 is 3. There's no variables, so leave the x squared as it is. 2 divided by 2 is 1, plus x. Negative 4 divided by 2 is negative 2. And that is how you would factor it. That is a technique that you can use to simplify your equation before you even begin. Now, the rest of it is very straightforward. Just factor this as you would a complex trinomial, and you will be done this equation. You can continue factoring this on a separate piece of paper. And yeah, just for some practice. But this was factoring as a whole, so doing simple trinomials, complex trinomials, difference of squares, perfect squares, factoring by grouping, and now you learned this technique. And if you go through my website, you will find that there's a lot more examples and many problems for you to try. But yeah, this is factoring. It seems very straightforward because it is. Just gotta remember to keep all the rules in mind. Product sum, similarity, complex trinomials is there's always people that goof up on the part where you're supposed to add the two numbers back into the original equation instead of just marking it down as your final answer. So yeah, this is factoring, and have a good day.